In this video, we're going to take a look at Pythagoras Theorem, which is a theorem that relates together all the sides in a right angle triangle. So we've got a diagram for a right angle triangle over here on the left, and the right angle is marked in the bottom right just there with a little square like that. Within this triangle, the one side that definitely has a name every time is going to be the hypotenuse, which is marked C in our diagram. It is the side that is directly across from the right angle. So Pythagoras' theorem states that the square of the hypotenuse is equal to the sum of the square of the other two sides. Now that sounds a bit complicated, but basically from this triangle here what it means is c squared is equal to a squared plus b squared. That's it. The c squared is the hypotenuse. Now in other triangles and other diagrams and other drawings of this, it might not be marked as c. C could be one of the other sides and a could be the hypotenuse. The main point is that it's always going to be the hypotenuse squared is equal to what you get when you square the other two sides and add those squares together. So let's take a look at a couple of applications of this. The first thing that can be done with this is it can be used to find the length of a side that we are not given within a right angle triangle. So we've got two right angle triangles here. We'll start with the one on the left. In the one on the left, what we're going to do is we're going to put together our equation, like above, with the values that we've got here in order to get a value for x. So we start with hypotenuse, which in this case is 5. It's directly across from the right angle. So we have 5 squared. And that's going to be equal to the other two squared added together. So x squared plus 3 squared. Okay, now we can actually square those numbers out. So we're going to get 25 is equal to x squared plus 9. And then we can bring the 9 over to the same side as the 25, leaving the x on its own. So we get 25 minus 9 equals x squared, which means that 16 is equal to x squared, which means that x must be equal to square root of 16. So x in this case is equal to 4, like that. Nice and straightforward. We just have to put our equation together, starting with the hypotenuse, and then just solve it out like we would any other algebraic expression. Let's take a look at the triangle on the right now. This time we have the missing side is the hypotenuse. So this is actually be a little bit easier this time. So we're going to have x squared, because we start with our hypotenuse, and that's going to be equal to 5 squared plus 12 squared. Well, 5 squared is 5 times 5, which is 25. 12 squared is 12 times 12, which is 144, which means that x squared is going to be equal to 169, which means that x is going to be equal to the square root of 169. So x is going to be equal to 13. So that's how we would go about finding the missing side when it's the hypotenuse and when it is not the hypotenuse. Now the other thing we can do with Pythagoras' theorem is we can use it to check whether a triangle is a right angle triangle or not. So we've got 3 different triangles here, each of them marked with different sides, and the angle marked theta may or may not be a 90-degree angle, may or may not be a right angle. And we're going to just try and figure out if it is or not. So we'll start with the first triangle here. If this is a right angle triangle, then that would mean that 6 is our hypotenuse because it is the longest side. And the longest side in a right angle triangle is always going to be the hypotenuse. So if we put together our equation, we get 6 squared is equal to 5 squared plus 4 squared, which means we have 36 is equal to 25 plus 16, which means we get 36 is equal to 41. But 36 is smaller than 41. It's not equal to. So it's actually not equal to 41. So that means that this is not a right angle triangle. But further to that, we're able to give an idea of what size the angle marked theta is. Theta in this case is actually less than 90 degrees. And the reason for that is that the square of the hypotenuse, this 6 squared is 36, was smaller than the sum of the squares of the other two sides. It was smaller than what we had on the other side of the equation. So that means that this angle here is less than 90 degrees. Let's try this again with the second triangle. This time around, our hypotenuse, if it is a hypotenuse, is going to be 10. So we have 10 squared. And that's going to be equal to 8 squared plus 6 squared. Which means we get 100 is equal to 64 plus 36. So we get 100 is equal to 100, which it is. Which means that in this case, theta is equal to 90 degrees. That is a right angle triangle, because all of the sides that we have put into Pythagoras' theorem satisfy the equation. In other words, we get the same thing on one side of the equation as we do on the other. Which means that in this case, this is proven that this triangle that we have, the second triangle here, is a right angle triangle. Let's look to our last one here. So for our last one, 12 here would be our hypotenuse, if it is in fact a right angle triangle. So I'll put this together, so we get 12 squared will be equal to the root of 104 squared plus 5 squared. Well, 12 squared is 144. The root of 104 squared is 104, and 5 squared is 25. So we get 144 is equal to 129, which it is not. In fact, 144 is greater than 129. So this is not a right angle triangle. And further to that, we're able to say that theta is larger than 90 degrees, because the square of the hypotenuse is larger than the sum of the square of the other two sides. This 144 is larger than 129. So we're able to say that our angle marked as theta here, the would-be right angle triangle, is in fact larger than 90 degrees. And that's Pythagoras' theorem.